Welcome to the tutorial on horizontal projectile motion. All right, so from the video analysis of the soccer ball or whatever target you were throwing and breaking apart, what we figured out was that the horizontal motion stays constant, meaning it's not accelerating, it's moving at a constant speed, but the vertical motion is accelerating in that vertical direction. And it's accelerating not only down, but also down at that good old negative 9.81 meters per second per second. So what we want to do is we want to sketch what the trajectory looks like, or at least prove that what we see being parabolic actually works out mathematically. So we have this cannonball that is being fired at 10 meters per second. So its initial velocity in the horizontal direction is 10 meters per second. And that we're going to basically trace it out from 0, 1, 2, 3, 4 seconds, and then figure out where it is and also how fast it's going. And we're going to make that assumption that the acceleration g which is approximately 10 meters per second squared, so negative 10 meters per second squared. Just to kind of make the math easy and able to do it without a calculator. It should be negative 9.81. So the initial position, what we're going to call the where the cannonball is being fired, right up here is going to be our 0, 0 point. And the fact that the horizontal motion is going to be constant, what that means is that in the horizontal, it's going to start off with 10 meters per second, and that 10 meters per second is not going to change. So every second of time, it is going to be going at that 10 meters per second. Organize it a little bit here. And then in the vertical, so if we scroll down here, the horizontal speed, the v, and I'm going to use the subscript x for the x or horizontal direction, is going to be equal to the initial velocity in that x direction. Another way of saying that is the acceleration in that x direction is 0. The vertical speed, we can calculate it using equation 3, Vf equals Vi plus At. And in our case, since we're talking about horizontal projectile motion, that initial velocity in the vertical direction is 0. So to kind of emphasize that, we can think about if we send something completely in the horizontal, notice that my arrow is directly to the right. It doesn't have any component up or down. What that means is that my initial velocity in that vertical direction is 0. So with that being said, we can cross off that VI term, and now we have just negative 10 meters per second times whatever time that we're dealing with. So the first time we're going to have is 1 second. So at 0 seconds, it's going 0 meters per second. At 1 second, it's going negative 10 meters per second. Okay, and these are all meters per second, so I'll leave off the units here. And at 2 seconds, going negative 20, 3 seconds, negative 30, 4 seconds, negative 40. Okay. Now, the horizontal distance, this dx term, okay, a couple ways of thinking about it, but I like to use equation 4, VIT plus 1/2 AT squared. And what we said is that since the horizontal motion is constant, that horizontal acceleration is 0. So this whole second term cancels out. So it's nothing more than the initial horizontal velocity, which was the 10 meters per second, times the first time, which would be 1 second. So at 1 second, it went 10 meters horizontally, 2 seconds, 20 meters, 3 seconds, 30 meters, and so on and so forth. So this is 10, 20, 30, and 40, and these are all in meters, meters, meters per second, and this is meters per second. Okay, so now the vertical distance, and this is where things get interesting. We're going to use that same equation for d equals VIT plus 1/2 AT squared. But what's kind of neat about this is that in the vertical, our initial velocity is 0. So this first term cancels out, and so I get 1/2 times negative 10 meters per second squared. times our first time, which is 1 second, quantity squared. So in the first second, kind of just work through the mental math here. So 1 squared is 1. 1 divided by 2 is a half. And then half of negative 10, we get negative 5. Okay. Next, we have 2 squared times negative 10 times a half. 2 squared is 4. Half of 4 is 2, and 2 times negative 10 is negative 20. Go through it again, and you can prove to yourself that the next one, 3 squared is 9. Half of 9 is 4.5. We get negative 45, and then we get also negative 80. And ask me any questions in class tomorrow if you are getting values that are different, but certainly check my math. Okay, so now what we want to do is we want to plot where this is. And so I added the 10, 20, 30, and 40 just to scale it. And what I did is 3 boxes here represented, 3 dashes there represented 10 meters. And then every dash up here was 10 meters as well. And that gets us just about to the ground at 80 meters. And so the negative here, all these negatives here just mean that it's going down, okay? So at 1 second, my coordinates are 10 and negative 5, okay? So that is 10 to the right and 5 down. So that would get me a dot somewhere right around here. So after the first second, this is at 1 second, the cannonball would be located where I just put that first dot. At 2 seconds, it would be at 20, 20. So somewhere right around here. Okay, at 3 seconds, it'd be at 30, 45. So there's my 30, drop a line down, and then drop a line over. Okay, it'd be right at that intersection. Okay, and then at 4 seconds, it'd be at 40, 80. Okay, so just about to the ground here. Okay, so that's where the cannonball will be every second. So this is at 2 seconds, this is at 3 seconds, and then this is at 4 seconds. And what you will notice is that if we sketch out that path, we get our classic parabolic path. Well, that's not exactly perfect, but we get a parabolic path down to the ground. Okay, so this is kind of a nice little way of proving that the shape will be parabolic. So in class tomorrow, we're going to do this little classic demonstration where we're going to drop a ball and fire a ball at the exact same time. Okay, so if we start analyzing the motion of each of the objects, all right, in the vertical direction, both of them begin with no vertical velocity. Okay, we're going to simply drop this one. It's going to fall down, straight down, and then we're going to fire this one. Okay, but in that vertical direction, which is represented right here, okay, both objects, right, there's no arrow going down. So both balls begin with no vertical velocity. Okay, both balls fall with the same acceleration. That is the acceleration in that vertical direction of negative 9.81. Okay, and then what we could do is we could find the time of flight by solving in either vertical or horizontal dimension. So this is going to be based on what you know more about, and that will be different from problem to problem. But what we can do is we can find the object displacement in either dimension using that time. Okay, so in all of these projectile motion problems, the first thing that you are going to be doing is finding that time. But what we can do is we can find the object displacement in either dimension using that time. Okay, so in all of these projectile motion problems, the first thing that you are going to be doing is finding that time. And then once you find that time, you can actually use that time to figure out the object's displacement. So whatever distance you're trying to figure out, whether it's horizontal or vertical, it can be done with that time of flight. Okay, so really kind of important concept that the time it takes to fall straight down, this time in the air would be the same as the time that it would take to fire out. Once again, same vertical distance that falls, same vertical acceleration, and same vertical initial velocity. And that's really important. So we have three variables that all are the same for both objects, so we get the same time in the air. All right, so we're going to do this one first example together, and then I'm going to ask you to do the second one as a follow-up. So we have an arrow that leaves a level bow at a speed of 45 meters per second. And its initial height is 1.5 meters. So we can kind of draw a little picture here. Here's my bow, there's my arrow, and we have a height of 1.5 meters. And I have an initial horizontal velocity of 45 meters per second. So we know, we just proved that it's going to take some parabolic path down to the ground, all right? And what we have here is an XY chart. So what do you know in the horizontal and vertical? And this is just a way to kind of help you organize your initial information. So a couple things that we can say just for any horizontal projectile, which this falls into that category, is the initial vertical velocity is 0. The acceleration in the horizontal is the motion in the horizontal is constant, so the acceleration is 0. And then in the vertical, it's negative 9.81, okay? And then you fill in the rest of the chart based on what you're given. So we know the vertical distance, which is 1.5. We know, and that would be negative since it's falling down. We also know the initial horizontal velocity, which is 45 meters per second. Okay, and that's it. So the first thing is how much time will be in the air. Okay, so if I go to my chart over here, what I will notice is that I have three pieces of information in that vertical direction. So I want to use the vertical to find that time. Okay, so if you notice, we have VI, A, and D, and we want T. That's going to get us down to equation 4, VIT plus 1/2 AT squared. And just to remind ourselves, we're working right now in the vertical direction, in the Y direction. Okay, so our initial velocity is 0. We have D equals 1/2 AT squared. We can multiply both sides by 2. That cancels out the 1/2. We could divide by A, and then we can square root both sides. So we get an expression that the time in the air is equal to the square root of 2D over A. Okay, plugging in our numbers, we have the square root of 2 times negative 1.5 meters over negative 9.81 meters per second squared. Okay, so when I did that calculation, I got a value of 0.55 seconds. So I put in my 0.55 seconds. Now, since the time is the same in just the horizontal, I have 0.55 seconds here. All right, so the next question is, how far away from the archer will the arrow land? What I'm looking for is that horizontal distance, that distance in the x direction. So I can also use equation 4 here, but in the vertical, the first term cancels out. In the horizontal, it's that second term that cancels out because my acceleration in that vertical direction is 0. So now I take my initial velocity of 45 meters per second, and then I multiply it by my 0.55 seconds. And when I did that, I got a value of 24.9 meters. And so 24.9 meters. Now, if I want to know what its horizontal speed is just before it hits the ground, this is a conceptual question. I want you to realize that, because what we said here is that the acceleration, wants to emphasize this, the acceleration is 0 in the horizontal. That means that the 45 meters per second is not going to change. So just before it hits the ground, it's still going to be going, that final velocity is still going to be 45 meters per second. Okay? All right, so I'd like you to take a look at this next conceptual question and then try out number 2 for homework, and we'll compare answers tomorrow. All right, thanks for listening. Have a good night. Bye-bye.